Okay, hello professor. So this is the second part of the videos. So let me just introduce. As I mentioned before, we are storing our videos in the, let me show you. So basically our videos are being stored in Home TT Tomato System Intelligent Monitoring V2, and inside the Intelligent Monitoring V2 we are I have created one folder called TCP video transfer just for keep all the logic inside of this folder. So as I mentioned in the part number 1, we have two main files, the video recording.py and the video sending main.py. I will skip the video recording.py because this is only recording, constantly recording the videos. But I will start with the videos and then main.py because this is in charge of the whole logic of our videos transfer with TCP. So we have the video sending main.py over here. What this code is doing at first is basically it will just check all the videos that we have stored in the camera, and to check for this, basically these few lines of code, they are just coming to database, camera records, videos, and tomato camera, which is the name that we have established for this camera. And what it is doing is that basically it is just checking how many videos do we have inside of this camera, and it will constantly be checking if we have more than 4 videos. And then if we have more than 4 videos or equal to 4 videos, it will start processing the oldest file and it will send it away. As you saw right now, there was a video of 7 p.m. 29 minutes, and it disappeared just now. Is because, as I mentioned, if we have more than 4 videos, basically we are gonna start running this code. Okay, so after we have checked that we have more than 4 videos, we will come directly to send the file. We are gonna be sending the oldest file, the file that was like 4 minutes ago. When we are gonna give it to this function, we are gonna give it together with the API server IP, with the port. We are gonna give the date of the videos, and we are gonna give the camera name. These last two is just in order to provide some information to the API server. Okay, so this file is coming from the TCP sender protocol, and as I mentioned before, this is the second Python file that we need for sending these documents. Okay, so we go to the TCP sender control py, and in here we have the main logic for the TCP transfer. And firstly, we are receiving the file, we are opening the file, we are reading it as bytes, and then as bytes, this is very important. Basically, we are opening the file in bytes and not in a regular way. And okay, then we initialize our connection, we turn on our socket, and we set a timeout. We set this timeout is just to make sure that if the connection was not successfully accomplished after 100 minutes, we will be closing the connection afterwards, just as a safety to avoid getting stuck trying to create a connection. And then we will start sending the connection to the API server to the specific port. And as you know, first we need to receive a confirmation. And so basically we try to establish the connection, we send our password, and then the API server will return an OK answer. If it does not receive an OK answer, basically we will have a message saying the authentication has failed, so we will return and we will finally close the socket. Okay, But if there was an okay answer, basically in here from this part to this part, we are just gonna be sending information to the API server, but we are gonna send the video's date, the camera name, and the video file name. We are gonna send this just for the API server to store the video in a better way. And we are also sending what is the size of the data we are sending. We are doing this just to make sure that the API server already knows how much data to expect and not to keep waiting after we have sent everything, but actually to finish waiting after we completely send the whole data. Okay, and so the main idea is that we are going to split the data. As I say, we open the data in bytes, and we are going to be transferring 20,000 bytes every time. And for that, we are basically moving windows in the data, and we are going from 0 to 20,000. Then we are going from 20,001 to 40,000 and so on. And we are sending this as a small chunk to the API server over here. Now, when the API server receives the data, it's very dangerous to just let our side to keep sending and keep sending. So in order to avoid overwhelming the network, we have created a system that receives a notification and acknowledgement, basically like saying, hey, okay, I'm ready to receive more data, please continue sending it. And if there is no acknowledgement, it means there has been an issue. We didn't receive any notification from the API server, and so we will finish the connection. And if there is an acknowledgement, basically we will just wait for a period of time, very small period of time, and then we will send the next chunk. Okay, so basically that's the main logic for the TCP sender protocol. So now let me just show you how is it working inside the system. So basically, just let me show you very fast the sender service. Okay, so over here we are in the sender service. We can see that after many acknowledgements, which means the API server was receiving data, we finally have a confirmation saying like, okay, I have finished sending this file successfully, and the name of the file was Tomato Camera 2025 May 7, and it was 7 p.m. with 34 minutes. In total, it requires 7 seconds to finish sending the whole data, and after it sends the whole data, it deleted it. And as you can see in here, is basically doing exactly that, is just taking the latest video and deleting it from here. So let me show you again. Now we can see the previous one was 7 p.m. 34, and the current one is 7 p.m. 35. So is taking the latest video and deleting it and sending it and then deleting it. Okay, so now let me explain very fast our Wi-Fi watchdog. And the main idea for Wi-Fi watchdog is that it is checking if we are having internet connection, and if we are not having internet connection, it will send a notification saying the Wi-Fi is down. We will try to restart it, and we will store this in the Wi-Fi log text. And basically, if it is down, we are just gonna make sure it is down. We are gonna turn it off just as a precaution, and then we will turn it on again. If the Wi-Fi is okay, then there will be just a small message saying Wi-Fi okay, and then there will be no issue. So let me show very fast. This is the log, and as you can see, most of it is Wi-Fi okay. At these times I was just trying to record the video, and so there was an interruption in the Wi-Fi, but as you can see later on, all of the Wi-Fi was okay. So now let me show again how does this work. So I will just turn off the Wi-Fi right now, and you will see that I am not able to access anything. And you can also see the latest time is 7 p.m. 41, and the Wi-Fi was okay. Okay, so I will turn off the Wi-Fi, and you can see that now it seems like if my computer has completely frozen, it is not going after this, and maybe I can try to open a random file, and you can see that it is trying to load, but since there is no Wi-Fi, since I lose the connection, now I'm not able to enter. So we are just gonna need to wait for 1 minute, and then the Wi-Fi will automatically connect by itself. Again, the one that will connect automatically is the Wi-Fi, but maybe I will still have to manually connect my SSH from my computer just to go inside. But hopefully it will be managed by itself. Okay, so now you can see that it was disconnected, and now I'm able to enter again. So IMIS Joel link, and okay, now I am inside of the API server again, which means the connection was successfully turned on again, and I can show you the connection was good at 7 p.m. 41, but at 7 p.m. 42 it find out that the Wi-Fi was down, and so it start to turn it on again, and now it is back to normal at 7:42. So now you can see that 7:43 the Wi-Fi is okay again. And basically that's it for the video sending protocol from the Tomato RPI. So thank you very much. I will continue the second video in the next part.